So students, in this semester, I will teach you a subject. The name of the subject is the digital signal processing. And this subject is the advanced version of the signal and system subject. And you can say that it is the advanced version of signal and system processing. Okay, so the syllabus of signal and system, DSP and signal and system is almost same. First of all, I will share the syllabus with you. This is the subject name is the digital signal processing and the code is the ACEC 16502. And the syllabus is again divided into the four section: section 1, section 2, section 3, and the section 4. So starting from the section first, we are having a introduction part, and in this chapter or in this unit we will cover the type of signals and the type of system that we have already covered in the signal and system subject. So first unit is almost we can say that it is 80% related to the 80% part is related to the signal and system. So first unit is very easy. It cover the concept of the different type of signals and a different type of systems and like a casualty LTI system, etc. And in the second unit we are having a Z transform, like we can say that Z transform, and it is like the introduction part we are having. We will do the numerical part of the Z transform. Then we are having a inverse Z transform also. So in the second unit, we will do the design of the digital filter. This is the new concept. The unit 2 is the new concept for you. We will do the Z transform. Like we have done the Laplace transform, we have done the Fourier transform. That similar type we will do the Z transform. Okay. And Z transform is basically for the type of for the digital type of signals. Okay, means Fourier we will do for the analog signal, then we will do the analysis of the analog signal. But in this Z transform is basically for the digital signals. So then we are having a design of digital filter and DSP processors. This is included in the unit number second. Third unit is the DFT, discrete Fourier transform, and its properties. This is the also very important chapter. We will do the fast Fourier transformation algorithm. We will do the discrimination frequency techniques. We will do the Gorstel algorithm. So this is the section third. It is the DFT actually. And in the section fourth, we will cover the concept of the filters. We will use the two type of filters in the digital, basically FIR filter, that is the finite impulse response filter, and infinite impulse response filter and its types. Okay, and in the last of the fourth section we will discuss the two different type of processors, like we are having a TMS processor, we are having a ADSP processor. We will discuss these kind of processors in this section 4. So this is the your syllabus of DSP. We will divided the syllabus into the 4 units, and CR कौन है class में? Nishikant.
Yes,
Nishikant,
sir.
today you will make a group of your one different group of DSP,
Yes, sir.
WhatsApp group. In that group, I will share the
Yes. Yes, sir.
like a daily notes. Okay, the part which we will discuss in the
Okay,
lecture,
sir.
I will
Okay,
share
sir.
the notes and PPTs in that group. Okay, so students will take
Okay, sir.
this copy of the lecture will share. Okay, so
Okay, sir.
today we will discuss the section first. That is the introduction part, and the like we will discuss the type of signals, and then we will discuss the type of system. This part we have studied in the signal and system also, but today I will give you the one broader view about this type of signals and the type of systems. Okay, so we will start today's a topic. Its code is the 5016165002. DSP is the subject name, and so first of all we will discuss in this PPT. We will discuss the like introduction to DSP, principle and operation of DSP, advantages and disadvantage of DSP, then applications and the conclusions. So uh, so today we will discuss these are the outlines of the first unit. First of all, we will discuss the introduction to DSP, principle and operation of DSP, advantages and disadvantage of DSP, application of DSP, and we will conclude the concepts here. Okay. So first of all, DSP is the digital signal processing. It consists of the three words. Okay. First of all, we are having a digital, then we are having a signal, then we are having a processing. Means first of all, you should know the meaning of the subject and the meaning of the subject name. Okay. So first of all, we will discuss the signal. What is the signal? So we will define the signal. It is a variable parameter. We can say that it is a variable parameter by which information is covered or information is thrown on electronic circuits. Or we can say that signal is a variable parameter by which information is conveyed from the one part to the another part. Or like is in the PPT, any physical phenomena signal, it is also defined as any physical phenomena that carries or convey information from the one place to the another place and represent as a function of independent variables such as time, distance, etc. So in short, if I will explain the signal, it is the parameter or that is a physical phenomena that convey the information from the one point to the another point, from the, or you can say from the one place to the another place. And it is the function of any variable. It is the function of time, distance, etc. So whenever we are talking about the signals, our signal may be our signal may be defined as the like along the x-axis we are representing the time, and along the y-axis we are representing the amplitude. So we are always represented the time along the x-axis. Why it is the x-axis? Because time is the independent parameter. Time never stops for anyone. So we all are dependent upon the time. So time is always along the x-axis because all the things are dependent upon the time, and time never stops for anyone. Okay, so we are taking the time along the x-axis. So next is the, what is the signal processing? Signal processing means we are modifying the signals according to our need. It is called the signal processing. Okay, we can also say that the signal processing is the analysis of the signals. Analysis of the signals means taking the information from the signals, or the we will do the manipulations of the signals. These are come under the category of the signal processing. If I am giving the examples of the real time, okay, so if I'm giving the example of the real time, like we are having images, okay, I will take the images from the camera. Then I want to send it from the one place to the another place. But first of all, I will take the images. The size of the images is very large. So what I will do, I will reduce the size of that image from the kilobytes. It is in the kilobytes. We will convert it into the bytes. Okay. So this is the kind of the signal processing. Means we are having any kind of like a video, then we will reduce the size of the video with the help of signal processing. These are examples which are come under the category of the signal processing. So we are having a two kind of signal processing. First one is the analog signal processing, and we will do the digital signal processing. Processing is always done in the both analog signal processing and the digital signal processing. So next we are having this is the definitions of the our subject, digital signal processing. Digital, first of all, digital means that is used discrete time signal. Digital means we are having two type of signals, continuous time signal and the discrete time signal. So digital means we are using the discrete time signal. Okay, so in this chapter, in this in this subject, we all are talking about the digital. We are only talking, considering only the digital cases. In the signal and system, we have taken the consider the analog signal as well as the digital signal. But in this subject, we totally talking about the digital part, and we are all dealing with the digital signals. So from the name of the subject, it is clear that it is operating by the use of discrete time of signals in the form of number. It is called the digital. Second one is the signal, like we are having a signal. So signal means a parameter that can be varied in such a way to convey the information. So signal is the, we can say that it is a parameter, or it is the uh, a signal may be defined as the variable parameter by which information is conveyed through an electronic devices or the circuits from the one place to the another place. Then third one is the processing. Processing means like doing operation on the signals or the modification of the signals. It is dealing with the processing. A series operation performed according to the program instruction, it is called the processing. What is the processing in the digital terms? In the term of the digital means we are having a set of program, because we are dealing with the digital, we are dealing with the bytes, we are talking about the number 01 number, the data is in the digital form. So means we are doing the work on the computer. Okay, so processing means it is the set of programmed instructions. Okay, it is the set of program instructions that we have to perform on the signal. Okay, that will modify the signal, change the signal according to our need. Okay, this term is called the processing. So digital signal processing means changing or analyzing information which is measured as discrete sequence of number. It is called the digital signal processing. So next we are having a below, we are, I am showing these are the elements of the DSP. Okay, so 2 marks question will came, explain the elements of the DSP, digital signal processing. So in the first, we are having the analog input. It may be a IF signal input. This is analog input. Here I have shown that it is the analogous signal. Okay, so this is the analog signal which I given to the ADC. ADC is the device. Uh, ADC is the device which is ADC is the device which is used to convert the analog signal into the digital signal. Means first of all we are having an analog signal. That signal is converted into the digital signal. Okay, with the help of first block is the ADC. ADC is converting the analog signal into the digital signal. Okay, then we are having the ADC output is the digital signal. So digital signal is given to the signal processor. Okay, this is our DSP processor. Okay, we are having a DSP processor. So it will modify it our signal according to our need, according to our requirement. It will process the signal. It will apply the like it will manipulate the signal. Okay, this signal processing is then goes to the DAC. Okay, DAC means digital to analog converter. Okay, this is the again we will after processing of the signal by the signal processor, this signal is again converted back into the analog signal. So this is done by the DAC. DAC means digital to analog converter. Okay, then here output is the analogous signal. Then this analogous signal is given to the audio amplifier, and here it is the speaker that will give the final output. Okay, so first of all we are having a signal in the IF signal. Okay, that signal we given to the ADC, then signal processor, and then we are having a DAC, then we are having a audio amplifier. So this is the last we are having a speaker. Okay, so this is the basic elements of the DSP. So whenever we are using the DSP processor, first of all we are using the ADC, then we are using the DAC. So this is the one drawback in using the DSP processor, that first of all we are using the ADC, then we are using the DAC, means the analog to digital converter, then digital to analog converter. This will make the system complex. Okay, so this is the one drawback of the DSP processor, ki we are required the ADC as well as the DAC. So these are the elements of the DSP processor. Next, we are having a like a why we need a signal processing, because this is the analog signal. This is the journal diagram. Basically, we will do the signal processing of the digital signal, but this is the journal diagram. Why we need a signal processing? Okay, so I will explain you this thing by why we need the signal processing with the help of this like a analog signal diagram. We are having this analog signal. Okay, so when this signal like when we transfer this signal from the one place to the another place, from the like I am transferring this signal by air. Okay, in the electromagnetic wave. So when I am sending this analog signals in the air, it will getting distorted. Okay, due to attenuation, due to different reasons. Okay, signal may get distorted when we are sending the signal in the air. Okay, so it get distorted. So this is the distorted signal we received at the receiver side. Okay, so I am sending this type of signal from the transmitting side, and it is getting the due to distortion, it wave shape get distorted. So at the receiver side, what I will do, I will perform the operation of signal processing. So signal processing, with the help of signal processing, I will modify this input signal. Okay, I will modify this input signal and make the signal similar to that of the input type. Okay, so we will remove the distortion with the help of the signal processing. This is the one example of the signal processing. Means we will remove the distortion with the help of the signal processing. So this is the principles and operation of the DSP. That digital signal processing consists of anti-aliasing filter, ADC, DSP, DAC, and a reconstruction filter. So again, this diagram is similar to the diagram that I have previously explained, that is the elements of DSP. In the elements of DSP, we have studied this part: ADC, DSP, and D to A converter. Okay, but now in this diagram we are talking about the anti-aliasing filter and reconstruction filter. Two new things are here. First one is the anti-aliasing filter, and the second one we are having a reconstruction filter. So what is the function of the anti-aliasing filter? I will explain you the concept of the anti-aliasing filter, that we are like I will explain you the concept of this anti-aliasing filter. Like we are having a main block is this one. We are having an input signal. Okay, here we are having a input signal. This is given to the ADC. Okay, this is the analog signal. It is saying that before you are giving the input signal to the ADC, you must apply here one more device, that is the anti-aliasing filter. Okay, that is the anti-aliasing filter. Then the signal will goes to the ADC, analog to digital converter. Why we need this anti-aliasing filter? Suppose my ADC is having the capacity that it will convert the 16 megahertz signal to the digital signal. Okay, each ADC is having their own specification, that on which frequency its work. So my ADC is working on the 16 megahertz frequency. Okay, so this is my sampling frequency. Okay, this is my sampling frequency of this ADC is the 16 megahertz. Okay, this is the specification of this ADC. So according to the sampling theorem, what the sampling theorem say? If it is sampling frequency is 16 megahertz, the input signal which is coming at this point, it must be of maximum value of the input signal must be 8 megahertz. It will not be more than the 8 megahertz. If your input signal is more than the 8 megahertz, suppose I am giving the 9 megahertz signal. Okay, so sampling frequency is required for this 9 megahertz is the 2fm. Basically we are having a formula of the sampling frequency is equal to 2fm. This fm means frequency of the input signal. Now we are having the fm value is the 9 megahertz, so it is the 18 megahertz. Sampling frequency is equal to 18 megahertz. But here the sampling frequency of over ADC is the 16 megahertz. So it will not work on this frequency. Maximum it will work on the frequency 8 megahertz. Okay, students. So before this ADC, so we will applying this anti-aliasing filter. Means I am working on this ADC. The frequency which is coming from the input side, it is the 10 megahertz. Previously it is coming the 7 megahertz, but it will suddenly rise. It will become a 10 megahertz. Okay. So what this anti-aliasing filter will do, it will pass the signal of the frequency of 8 megahertz only. This will pass only the frequency of 8 megahertz. Rest the above frequency, it will be attenuated by this anti-aliasing filter. So this is the concept of the anti-aliasing filter, that our ADC will work on the 16 megahertz frequency. So according to this specification, we are providing here the anti-aliasing filter. So anti-aliasing filter what this anti-aliasing filter will do, it will attenuate the frequencies which is more than the 8 megahertz. Okay, because according to our formula, fs is equal to 2fm, so our sampling frequency is the 18 megahertz. Okay, so this is the concept of the anti-aliasing filter. So whenever we are using the ADC, we will first of all we will applying the anti-aliasing filter. Okay, then in the last we are applying the reconstruction filter. We are applying here ADC, then we will apply the DSP, then DAC, then here we will applying the reconstruction filter. After the DAC we are applying the reconstruction filter. Reconstruction filter will do the concept of like same. It will reconstruction filter will remove the unnecessarily frequencies. Okay, here we are applying the reconstruction filter. It will remove the reconstruction filter means it will reconstruct our signal. Okay, means after the DAC the signal is converted into the analog signal, so it must be reconstructed by this reconstruction filter. So these are the elements of the DSP. Whenever the question came in the examination, explain the elements of DSP, you must draw this diagram. First of all, input signal, then anti-aliasing filter, then ADC, then DSP, then DAC, then a reconstruction filter. In the last, then we are having the output signal. Okay, so these are the principles and operations of the DSP. So next, like we are having a filters. Basically, we are having a two types of filter: digital filter and the analog filter. So in this, in this subject, we will discuss the different types of digital filters. And digital filter basically divided into the two categories. One is the finite impulse response filter. Second one is the infinite impulse response filter. So in this chapter, in this subject, we will study this finite impulse response filter and infinite impulse response filter. So these are the diagrams of the analog filter and the digital filter. So we are having a number of advantages of using the digital filter as compared to the analog filter. Digital filters are having number of advantages. Basically, in our analog filter, it is consist of the resistance and the capacitor. Okay, we are using these components: RL type filter, RC type filter. But in the digital filter, it is computer based, and here we are using the Z transformation concept to design this digital filter. Next, these are the advantages of the digital filter. We will process the data, we will generate the data, we will save this digital data, and there are the number of advantages in by using this digital filter are superior, and its performance is much better as compared to the analog filter. This digital filter we will discuss in detail in the chapter number 4 of the DSP. Next, these are the advantages of the digital filter. It is the DSP filter is immune to environmental change. It does not depend upon the environmental change. It does not depend upon the noise, and it does not having the problem of impedance matching, commutational problem, and their availability of digital filter is they will do the multiple filtering at a time. They will perform the multiple level of filtering. They are having a variety of shapes for amplitude and phase response, easy transformation and reconfigurations. So Next, we are having the advantages of the DSP. So advantages of the DSP like accuracy, flexibility, easy operation, multiplexing, storageable. So these are the advantage of the DSP. We will discuss the one by one. First of all, we can say that the DSP, digital signal processor, is versatile. Means digital signal processor as compared to the analog signal processor. So it is the versatile. This is the first advantage of the DSP processor. The first advantage is the versatile. Means our digital signal processor is the processor which we are used on the computer. Okay. So digital system can be programmed for other applications. Versatile means the DSP processor, it is used or programmed for other application. It must be programmed for many application. Okay, means in the case of the analog signal processor, must be used only for the specific purpose because it is the hardware. We have to construct it by the resistance value, capacitor value. But this DSP processor we will make in the computer. So it must be DSP processor must be programmed for the many applications. Means it can be ported to different hardware also. So this is the first advantage, the versatile. It can be programmed for the many applications. Okay. Second one is the repeatability. Okay. Repeatability. Repeatability means it is easily duplicate. Means I have created one type of DSP processor. We will create the similar type of DSP processor, another DSP processor. Means it is easily duplicated and does not depend upon the component values or component tolerance and the temperature. In the case of ASP processor, what will be happen means it is depending upon the value of the component values, okay, value of R, value of L, and its tolerance value. So this concept is basically used in the analog signal processor, but we are not using this concept of like a component values, its tolerance in the case of DSP. So next we are having the advantage that it is the simplicity. Okay, it is our DSP processor is the easy to build. Okay, it is simplest. Okay, next we are having like a accuracy. Accuracy. Okay, accuracy is the means the output value that this is design analog system, analog components in the analog signal processor. Like first of all, we are talking about analog signal processor ASP. In this processor, the accuracy is depending upon the value of R, value of L. Okay, so it will not give the 100% accurate result because there is some tolerance of these components. These components are affected by the temperature. Okay, so in the case of DSP, we are not using the resistor, we are not using the inductor. Okay, so here it is the computer operated. So accuracy is more in the case of the DSP processor. Okay, so accuracy is more in the case of the DSP processor. Next advantage we are having like a remote processing. Remote processing means Fifth advantage, we are having like a remote processing. Okay, remote processing means we can easily send DSP processors or uh, we can easily store the data of the DSP processor. We store and send the data of the DSP processor from the one place to the another place. So it is easily, remote processing is easily in the term of DSP, and it is very tough in the case of the analog signal processor, because in the case of analog signal processor, the remote processing is very difficult, because the R value, resistor value, the inductor value is changed in that. Okay, so there is the problem of the remote processing. Then multiplexing is possible. Okay, we are using the multiplexing techniques in the DSP processors. Okay, we can send a large amount of data by with the help of multiplexing, storageable, and it is easy operation, easy upgrade. We can upgrade it easy. In the case of the, it is easy upgrade means if we will upgrade the analog signal processor, we have to change the hardware, but here we will change only the program. Okay, so it is easily upgraded. DSP processor is the easily upgraded. Okay, so these are the advantages of the like our DSP processor, and we are having the limitations of DSP processor also, or we can say drawback of DSP processor also. So what are the drawbacks of the DSP processor? First one is the, we are having the system complexity. Okay, so I will explain you these 3 points also: anti-aliasing filter, frequency resolution, quantization error also. So first of all, we will discuss the system complexity. Okay, what is the system complexity means? Means we are using this DSP processor. Before this DSP processor, we are using the analog signal. We will use the analog to digital converter. Then we are using the digital to analog converter. So we are, when we are using this digital signal processing, we are using this ADC. Then we are using this DAC. So this will make a system complex. Okay, these two things will make a system complex. ये क्या करते हैं? This will make a system complexity is increased when we are using this DSP processor. This is the one drawback of the DSP. Okay, so next one, we are having a bandwidth. This is the first drawback. Second drawback is the, we are having a bandwidth problem. Okay, so next we are having a bandwidth problem. Okay, so what is this bandwidth problem? So in the DSP processor, like this is our DSP processor. First of all, we are using this ADC. Okay, suppose this ADC is working on the 16 megahertz signal. Okay, this is working on the 16 megahertz signal. So maximum input signal, its sampling frequency is 16 megahertz. So if my input signal is of more than 8 megahertz, okay, this ADC will not work. Okay, if my input signal is more than the 8 megahertz, this ADC will not work for that kind of signal, because its sampling frequency is the 16 megahertz. So there is the bandwidth problem. Means this DSP processor will work only for the this 16 megahertz. Okay, if we increase the frequency, or if we increase the bandwidth of the input signal, then we have to change this ADC processor, and we have to change this DSP processor, because these processors are limited with respect to the frequency. These two are depending upon the frequency range. Okay, means if we are changing the frequency, if we are changing the bandwidth, we have to change this hardware also. Okay, so this hardware, this is the problem in the DSP processor. Means if we are changing the input frequency range, we have to change the hardware. Okay, so this is the bandwidth problem, or we can say that the frequency resolution. Okay, so third one drawback is the power consumption. So like in the DSP, or if you have seen the motherboard of your computer, okay, so it is consist of the number of components on the one hardware. Okay, so third problem is the power consumption. Okay, so power consumption is more in case of power consumption is more in case of DSP processor. So this is the one more drawback of the DSP. Power consumption is more in the case of the DSP processor. Next, fourth, we are having a quantization error. Okay, quantization is the process when we are converting the analog signal into the digital signal. We will do the quantization. When we are using this quantization concept in the ADC, there is the error. Okay, quantization error is occur when we are converting the analog signal into the digital signal. So this is also the drawback of the DSP. Means when we are converting this analog signal into the digital signal, the quantization error is occurred. So this is the basically like a introduction of the DSP. What are the elements of DSP? Where we are using the digital signal processor. So what are the advantage of DSP? What are the drawbacks of DSP? So next, we are having a number of applications of DSP like image processing. Image processing means I have taken the one image, okay, from my camera. I will do the modification of that images. I will increase the contrast. I will like reduce the size of the image, and your applications like Instagram, okay, and your Facebook, your Snapchat, they are using this application, digital signal processing. Okay, they are using the concept of digital signal processing. Means you can change your photographs, you can change your contrast. This is the image processing. This all will come under the image processing. So here I am showing you the one figure, that is the figure A, and the after the processing, image processing, it the same image I will show you in the figure B. So this is come under the category of the image processing. We will increase the size, we will reduce the like we are having a number of applications in the image processing. We can reduce the size, we can increase the contrast, we can generate the like a modified our images according to our need. These all come under the image processing. One more example I will give you in the image processing, that I have taken the one images, that image is in the like a haze. Okay, in the winter season we are having the haze. Okay, and I want to see that picture clearly. So with the help of the image processing, or we will apply the different techniques, we can reconstruct that images. Okay, so next one is the cellular mobile phones. We are having a number of like in the like in the cellular mobile phones, we are using the digital signal processing. Like first of all, I will give you the one example, that when we are do a calling, when we will do the calling in the foreign country previously, there is the echo is there. So to remove that echo, we are using the digital signal processing. And one more example I am giving here. Before like 3 or 5 year, when we are doing the call to the in the foreign countries, there is the time lag between the over voice and the from the voice from the receiver side. So that time lag also improve with the help of this digital signal processing. Now there will be a no time gap in between. In communication fields, we are using the digital signal processing to reconstruct the signals. Okay. And in speech and music, we are using the DSP processors, like we modified our voice with the help of DSP processors like this one. Okay. We will reduce the speech, we will reduce the music clips, etc. In biomedical field, we are using this DSP processor also, like in radar and sonars, we are using the DSP processor also. So we are using this DSP processors in number of applications. Okay. So next we are having a conclusion is the digital signal processing is our need of our era. We are using the digital signal processing in every field, every applications, like in medical field, like in different fields. And we are having a storage capability also. We can store the digital signal. We are having a number of advantages of the digital signal processor. We are having a number of applications of the digital signal processor also. Okay, so these are the brief about the digital signal processor. So this is our first introduction part. Kindly, now we will discuss the type of signals. So one student, kindly, beta, if you are having a